Let's suppose we've got a complex number which is 3 plus 3i. So we could put that on the Argand diagram. If we go 3 along the real axis and then 3 up, we can put that point on the Argand diagram. So that's our coordinate. That's our point z equals 3 plus 3i. One way of referring to this point in the Argand diagram would be to use a coordinate or a position vector. As a coordinate, it would be 3, 3. And that's actually called a Cartesian coordinate. The Cartesian coordinate tells you how far to the right do you go and how far up do you go to get to our point z. Another way of describing this complex number is to use something called the modulus and the argument. So in order to describe how to get to this point, we're going to give two pieces of information. The first piece of information is the modulus. The modulus of z is how far away is z from the origin. So in this case, we can use Pythagoras to work out the modulus. In fact, we're always going to use Pythagoras to work out the modulus by drawing in a right angle triangle like that. And we know that this length is 3 and this length is 3. So we can just work out the hypotenuse, square root of 3 squared plus 3 squared, which is 3 root 2. A shorthand way of writing the modulus of the complex number z would be to use the modulus symbol like that. So it's exactly like the length of a vector. You're basically working out the length of that position vector 3, 3. Well, there's actually an infinite number of points that are a distance of 3 root 2 away from the origin. You could draw a circle of radius 3 root 2 and all those points would have this modulus. So we're going to need another piece of information in order to describe where this point is. And the piece of information that we give is the angle measured from the positive real axis, so measured from that green line. So all the points along this green line, along the positive real axis, would have an angle of 0. We call the angle the argument of the complex number. So, and we measure it, the positive direction is this direction like that. So if you use the unit circle, it's exactly the same notation as the unit circle. So in this case, we're moving in the positive direction because we're moving anti-clockwise. And we want to work out what angle do I need to turn from starting from that green arrow to end up facing the complex number z. So we basically need to work out what is that angle between the green arrow and the vector to our complex number. So let's call that angle theta. So we can use tan to work out theta. So tan theta equals opposite, which is 3 divided by adjacent. And if you work that out, we're going to use radians, you'd get pi over 4. So this is what we call the argument of our complex number. So let's write that down. A shorthand way of writing argument is argz. So you'll see that written a lot, rather than having to write out argument of z each time, just argz. Let's look at a quick example of where a complex number would have a negative argument. If instead we had a complex number, let's call it alpha, which was 3 minus 3i, then our vector from the origin to the point would be like that. And you can see that if we start at the 0 angle, so start at the green arrow, we need to describe what angle do we need to turn in order to get to this black line down here, to get to alpha. And that angle there is also pi over 4. But we need to distinguish the fact that we've gone, this time we've gone down from the real axis, so we've gone in the clockwise direction. So this is the negative direction for the argument, for the angle. So for this complex number, you'd say that the argument of this complex number is minus pi over 4. Okay? And that tells you that you're going to spin pi over 4 in the clockwise direction. So let's have a look at example 4 then. So we've got this complex number and we need to find out what the modulus is and what the argument is. So I'd always recommend drawing a sketch of the Argand diagram. and we've got a complex number with real part 2 and imaginary part 7. So let's put that on our sketch. So this is a complex number z. So in part A, we want to find the modulus of z, which I'm going to use the shorthand notation modulus of z. We're going to draw in the line from the origin to the complex number, and we're going to create a right angle triangle like that. So we can use Pythagoras to work out the length of the hypotenuse. Remember, this length here is the modulus of z, the length of that black line. So we're going to do square root of 2 squared plus 7 squared, which is root 53. For part B, we want to find the argument. So we basically start by facing in that direction. That's our kind of like 0 angle direction. And we want to describe what angle do I need to turn to get from the green arrow to pointing towards z. So basically, what's that angle there? So we know that tan theta, opposite theta is 7, and the adjacent length is 2. So 7 over 2. And then we're asked for our answer to 2 decimal places, and we're always going to use radians. So even if the question didn't say radians, you're going to use radians. And if you work that out, you get the argument of z equals 1.29. And what we mean by that is we mean plus 1.29. You don't need to write the plus because obviously you don't need to do that. But that means that we're going to turn in the anti-clockwise direction, because that is the positive direction.